All right. So as we look at scale drawing, okay, as the book says, it is a diagram of an object in which the dimensions are in proportion to the actual dimensions of the object. Okay, so that's a scale drawing. Now, the scale is the ratio of the scale drawing between the actual and model. Okay, so in your book, they've given you that floor plan of obviously the bottom part of a house, or the top part of a house, one of the two, probably the bottom part, since your kitchen's there. Usually the kitchen is on the bottom floor in the United States. Other places it's sometimes on the top floor. But they've given you that floor plan is what they call that. Okay, it's a scale drawing, but they call it a floor plan. It's what all builders use. It's a little bit more complicated, the ones actual builders use, than that one right there. But that's a scale of an actual house. The scale of that scale drawing, if you look at the top left-hand corner of the picture, it says 1 inch. It says 1 inch colon 12 feet. Okay, that's the scale for that particular drawing. Every drawing is going to have a different scale. Okay, now you might run across some that are the same, but so what they're basically saying is if you measure an inch on that picture, it's equal to 12 feet in real life. Okay? Mr. McDaniel's not here yet this morning. I was going to try to get the floor plans of this school. Obviously, you can't make plans for a building the same size as the building. Okay? I mean, how hard would that be if they built this school and the plans to build this school were as big as this school? Okay? I mean, you can imagine having to roll out a piece of paper the size of this building to build the building. Okay? It's impossible. Okay? So obviously, they have to shrink things down. Okay? And there's a certain scale. The plans for this building actually would fit on this table. I've actually seen them. Okay, you roll it out, and it'd be about maybe a little longer than this table. Not much. I've actually seen them in there. He's got literally that closet right over there in the hallway. He's got a box that's probably, or actually it's this one here. It's got 4 shelves of just big old rolls of floor plans just stuck in there. Because they have to do electricity, they have to do plumbing, they have to do just everything. That little outlet on my wall over there is on the floor plan. Okay, and it's the correct distance from each end and all that. I mean, everything in here is measured. It's not just like, hey, let's stick a plug here. Okay, that's a good place for a plug. Let's put it in the closet. Well, obviously you wouldn't put a plug in a closet. Okay. Right over there in my little cabinet. So let's put a plug in these cabinets over here. That's a good place. He won't need to use it. All right. So everything that you see that is built, any kind of building, any kind of structure, any kind of landscaping. Okay, even landscaping is detailed on scale drawings. Okay, so another one of those deals, we talked about proportions the other day. We talked about ratio and proportions being one of the things that you would use in your daily life or affects your daily life, one of the main things. Scale drawings is that as well. Okay, so they've got to have a drawing for every tile that's in the ceiling up here. Where the lights go. If you look at the rooms, all the lights are in the same spot. If you ever look at the ceiling, which I know you have because you're always in that, that dazed, I'm at school, I better wake up. Okay. Nicole, she's got the carpet figured out because she's always looking down at her desk with her head down on it, so she knows all the carpet in the building. Some of you got catch flies with your mouth because you're sitting there with your mouth open and leaning up. We could stick a gumdrop down there and choke you to death. All right, so everything in this building, everything it's in your house. Okay, your house was built by a specific floor plan. All right, so that's what they are. Floor plans are scale drawings. Scale drawings happen in every single item that is three-dimensional. Okay, anything that is three-dimensional. Okay, it has depth, it has height, and it has width. Okay, anything that's three-dimensional, there is a scale drawing somewhere of this desk that you're sitting in. Okay, the manufacturers didn't just start piecing things together and go, oh, look, I got a desk. It wasn't like just they threw a bunch of things together and go, oh, that was a refrigerator this time. Okay, they have actual drawings that they go by. Obviously, for a desk, the scale drawing is going to be, you wouldn't have to have 1 inch equal 12 feet. That would be sort of stupid. Here's an inch, here's 12 feet. Well, the desk is only 2 feet, so what am I going to do? Okay, then you have a small drawing like that above a desk. So, a scale can change. They're used in floor plans, they're used in maps, okay, and they're used in scale models. How many of you have ever built a model before? Like a car, a plane, anything. You ever built a model? How many of you have ever done the little Lego sets where you build a big thing, not like just, hey, look at my creativeness, okay? You're actually building like a ship or something like that. All those things, if you've ever built a car, if you've ever built a plane, if you've ever built a boat, a ship, those are done to scale. Okay? And a lot of times you'll see it on the box. It says scale 1:14. Okay? Well, what that may mean is for every 1 inch of your model equals 14 inches on a true car. Okay? And so scale models are exactly the same thing. When they build a car, they start with a model, usually made out of clay. Okay? They'll make it out of clay, then they make it into something else, and there's a very long process for those cars to eventually make a car. Okay, it's just like the desk. They didn't just go in a factory and start throwing things together and go, hey, that looks like a car. Okay, it looks like a Mercedes. Let's put a Mercedes emblem on it. Or that looks like a BMW. Okay, they have actual drawings, actual models that they've done all their work on before they go to the big thing. Okay, so the scale is what the ratio is. Look at the map there in example 1 on page 400. Excuse me. Who can tell me what the scale is of that map? Tristan. Yeah, so 1 centimeter equals 65 kilometers. Okay, so you can measure on that map, that's Maine. Why you name a city, China and Maine, I don't really know, but hey, so be it. They're northerners, they can do whatever they want to do. You have New Sweden. They named them all countries in Europe, I guess. I guess they like countries in Europe and Asia. No Fort Worth or Dallas there, boys. We got China, Maine, and Paris, Maine, and New Sweden, Maine, and probably got a Switzerland, Maine, and Yankees. All right, anyway. Probably shouldn't say that since that's on YouTube. But anyway, so in here they ask, okay, they want to know on the map, estimate the distance between the towns of China and New Sweden. Okay, and what they've done is they've actually measured it. It came out to be 4.5 centimeters on the map. So they want to know how much actual distance that is. And so what they've done is this. This is example 1. I'll do some out of the book as well, but I just want to start with this one. Example 1. So they said that our scale is 1 to 65. So 1 centimeter is 65 kilometers. Okay, and they said that the scale distance was 4.5 centimeters. So they want to know how much actual distance that is. Well, when you're dealing with the scale, okay, your scale will always be the scale distance over the actual distance. That's what the ratio will always be. It'll always be the scale over the actual, okay, or the model over the actual. That's what your ratio always is for scale. It's always the small distance over the large distance. Okay, so in this one, we are going to set up a proportion that has this, scale and actual. So we know that our scale is 1 over 65. We know that the scale on our map is 4.5. So we're missing the actual distance. Okay? Now we're just going to take and solve it just like we've been solving proportions. We're going to cross multiply and solve the equation. This one's a fairly easy one because when we cross multiply, we get 1 times x is equal to 6.5 times 4.5. Okay, and so that gives us x is equal to, 1x is equal to 292.5. Well, 1x is just x. Okay, that's just x, and so x would be 292.5 kilometers. Okay, so to go from New Sweden to China, here's the point here. Understand that on a map, you can always go from straight line from one point to the other. Okay, so we're just estimating what they call the flying distance or the air distance. Okay, obviously from New Sweden to China, you can't go directly because if you draw a straight line between those 2 points, you run across that little lake in the middle of the picture. So obviously we're not going to drive our car across a lake unless there's a big bridge. Okay, you're not going to drive underneath the water. All right, so remember, when you're looking at a map and finding distance, you're finding air distance. Okay, a lot of times on GPSs, when they can't locate your point right away, they'll give you the mileage to your destination in air miles. Mine does that quite often when it can't, hadn't found my GPS or I just turned it on, put in a place I want to go, it'll come up and say air. And it'll have a little, I can't remember what the little picture is beside it. And then it eventually finds my GPS position and it goes to, actual miles and actual routes. Okay? So, that's how we find it on a map. Okay? Same thing goes for a scale model. All right, everybody turn to page 402. On page 402, I want you to look at number 12. Okay, I want you to look at number 12. Number 12 says, the directions say, we're talking about model airplanes. It says, the scale used to build scale models of 4 airplanes is 1:72. Okay, estimate the actual wingspan of the airplanes given the wingspan of the models. So they're building these models that we talked about a while ago. Okay, they happen to be airplanes. So you're building an airplane model. When you get done with this airplane model, number 12 says the Kitty Hawk Anybody remember what the Kitty Hawk is? It's a plane, obviously, since it says we're building model airplanes. I would assume it's a plane. I can't remember the Kitty Hawk or the Spirit of St. Louis is the one that the Wright brothers flew. Was it the Kitty Hawk? Very first airplane. They flew off a cliff and it actually flew instead of not, and they didn't die. Yeah. Okay, so the Kitty Hawk wingspan. In other words, they're looking at a plane like this, and here's the wings. Okay, nice plane. All right, and they're saying from here to here on the model, from there to there is 17.1 centimeters on the model. Okay, they want to know what the actual distance is. Okay, now, here's how you find it. We set up our proportion. The scale ratio was 1:72. So that's 1/72 equals, remember, this is scale over actual. Okay, so the scale was 17.1 centimeters. Over the actual, we don't know.
Oh, I have a question. You know how, like, whenever you put that sentence where you're supposed to multiply, how come on the other one you changed it to 7.2? Like, you're 55 and you changed it to 6.5.
Do what now?
Like, it was...
Up here? Are you talking about up here?
Yeah, now I'm asking you about this one. Okay, because on the other one you put it was 1/65 and then you put 1/65. I mean, 1 times... I know what you're talking about. Okay, on this one, you changed to 7.2. It's like...
7.2. I'm not seeing a 7.2.
Yeah, on the other problem, the number was, I think it was 65 and you put 6.5.
No, I didn't. No, there's no 6.5. It says 65. Oh, my bad. No, that's a speck. That's a speck on the drawing. That's not an actual. Okay, I understand what you're saying. Yeah, it should be that right there.